All right, each one of these 4 problems are going to come up in the notes, so let's see what we get for these answers. Number 1, I'll remind you, I is the square root of -1, and we only use that for square roots, so we're not going to use that for these 4 problems. I squared equals -1, we use that wherever it shows up. All right, so in number 1, if your gut tells you that when you're multiplying 2 things times 1 thing, that you should distribute your guts right. Multiply I times, multiply I times 4, and multiply I times I. Oh, it's frozen? Where's that? There it is. All right, so I times 4 and I times I. 4I plus I squared. And then there's that I squared, so you can replace it. 4I plus -1. And the final answer is 4I minus 1. But I'm going to put it in the order that the complex number A plus BI goes. The order is real part first, -1 first, imaginary part second, positive 4I. So it's a complex number. Number 2 is a pure imaginary 5I times a pure imaginary I. And when you multiply pure imaginary numbers, 5I times I is 5I squared. Again, we replace -1 for I squared, and we get final answer -5. So when you multiply pure imaginary numbers, you get a real number. When you multiply pure imaginary numbers, you get a real number. Number 3, distribute 2I times 3 and 2I times -6. So 6I minus 2 times 6 minus 12I squared. Again, the I squared turns into -1, making this 6I plus 12, or in the complex order, 12 plus 6I. And then the last one, when you're multiplying 2 things times 2 things, you distribute the things to the other 2 things. And in Algebra 1, you probably called it FOIL, F-O-I-L. So one at a time. F, 3 times 3, 9. Outer, 3 times -6I, -18I. Inner, 6I times 3, bless you, positive 18I. And then last, 6I times -6I. Careful. -36I squared. All right, now I'm going to pause just for a second and point something out. We just multiplied 2 complex numbers. We're not done with it, but there's a special relationship between these 2. 3 plus 6I and 3 minus 6I, they're called something. They're called conjugates. C-O-N-J-U-G-A-T-E-S, I think. Yes, that's on the back of your notes there. Conjugates, complex conjugates. And something special happens when you multiply them. The middle 18 I's cancel. And you have 9 minus 36 times I squared, which is -1. So it becomes 9 plus 36. So what's the special thing that happens when you multiply complex conjugates? You get a real number. The I goes away. Okay? So now we're going to use these 4 answers to finish our notes. I kind of already introduced the concept of conjugate. But on your notes here, A plus BI is a complex number, and A minus BI is its conjugate. All right, now your notes, I don't know why I haven't fixed this yet in like 3 years, but it says 3 plus 6I and 3 minus, yours says 2, that's a typo. 3 plus 6I and 3 minus 6I are examples of conjugates. A half plus 4I, a half minus 4I. -3 plus 2I, -3 minus 2I. What's the conjugate of 2 minus 5I? Yeah, 2 plus 5I. So you get it, right? Why are we talking about it? Because when you divide imaginary numbers or you divide complex numbers, learning target 6 is dividing imaginary, pure imaginary. 7 is dividing complex. You're going to need that fact. All right. Division's a little weird. Adding, subtracting, and multiplying was natural yesterday. Whatever you felt like you should do was what you should do. All right? Division, not the case. To divide a complex number, 4 plus I, by a pure imaginary number, 5I, to divide by 5I, You can't just take 4 and divide it by 5i and divide it by 5i. Yes, the I will go away in the second part of that, but the first part, the I will still be in the denominator. In other words, you haven't divided by the I. All right, so you have to do something kind of weird. All right, you have to multiply this fraction times something to do the division. To do the division, you have to multiply it by something to get rid of that I that's in the bottom. So you'll multiply the top and the bottom by I. We've already seen it in the bell work number 2. What happens when you multiply 5i times I? It becomes negative 5. So the denominators, and by the way, I glossed over this. How do you multiply fractions? You multiply their tops, and you multiply their bottoms, right? And if you multiply 5i times I, no more I in the denominator. You've successfully divided by 5i, but you did it in a weird way. All right, so we'll look back at those bell work answers. 4 plus I, that's the top of the fraction, is being multiplied by I. We've already got that answer. 5i is being multiplied by I in the denominators. We already got that answer. So let's look back. What are those two answers? Let's see, the first one is negative 1 plus 4i, and the second one is negative 5. So negative 1 plus 4i is the top of the fraction, and the bottom is negative 5. We've successfully divided by 5i. The i's gone in the denominator. Now let's put it in the right form, a plus bi. So break this fraction apart into two different numbers, the real part and the imaginary part. The real part is a negative 1 divided by negative 5, which is positive 1/5. The real part, a, is 1/5. The imaginary part is a negative because it's a positive 4 divided by negative 5, positive 4 divided by negative 5. So it will be negative 4/5 I. I didn't think about this before, but last period asked about it, so let me bring this up. 2/3 x. 2/3 x looks like that, right? That's the same thing as 2 times x divided by 3. Those are equivalent expressions. Okay, so when you look at this, how I turn that into 4 over 5 times I, the I is still in the top of the fraction. We're just writing it out to the side to make it look like a complex number. Okay, all right, moving on. So that's your final answer. And yesterday we kind of drilled this in the ground. When you multiply, when you add, and when you subtract complex numbers, you get a complex number. What do you get when you divide them? A complex number. All right, learning target 7. Now we're dividing by 3 plus 6i. Dividing by 3 plus 6i. So we can't just divide by 3 plus 6i. We have to multiply by something that's going to get rid of the I in the bottom. Well, don't write this down. But what if I multiply by I in the bottom? What would I times 3 and I times 6i become? Well, it would become 3i minus 6. So all it would do is move the I onto the 3. So you can't do what we did above. To do this division, you have to multiply by something that gets rid of the I in the denominator, and that something is the complex conjugate. Multiply by the complex conjugate of the denominator, 3 minus 6i. And then do the same thing to the top. Essentially, you're multiplying this fraction by the number 1. A special 1, and it will get rid of your I in the denominator. All right, so scratch work. Multiply 2i times 3 minus 6i. And multiply 3 plus 6i times 3 minus 6i. Both of which you already did in the bell work with me. So let's look back to the bell work and get those two answers. Let's see, multiplying 2i times 3 minus 6i gives us 12 plus 6i, and multiplying the conjugates 3 plus 6i and 3 minus 6i gives us 45. So we'll take those answers and put them in. 12 plus 6i and 45. So the top becomes 12 plus 6i, and the denominator becomes 45. All right, you should be able to do this reducing in your head, but just in case, 12 divided by 45 is the real part, and when you hit math enter, the reduced fraction is 4 over 15. So the real part of this answer, 4 over 15. The imaginary part, 6 divided by 45. Math, enter, 2 over 15. So the imaginary part, 2 over 15 I. And that's division. There's one more, and I want you to do it. I want to get you started just with thinking you're dividing by 2 minus I. Dividing by 2 minus I, that's what that's saying. What do you multiply by? 2 plus I. You multiply, not 3 minus I, okay? You're not trying to get rid of the I that's in the top. You're trying to get rid of the I's in the bottom. You're trying to perform the division. So you multiply both the top of the fraction and the bottom by 2 plus I. So I'll set my scratch work up over here. 3 plus I times 2 plus I. And 2 minus I times 2 plus I. And I'll pause the video and let you try it. All right, gave them a little time to practice it, to work it out. So now my work, 3 times 2, 6. 3 times I plus 3I. I times 2 plus 2I. And I times I plus I squared. So we get 6 plus 5I. Then I squared becomes -1. So we end up with 5 plus 5I for the top. Top of this fraction, 5 plus 5I. The bottom, if we do our work right, it shouldn't have an I in it. It should just be a number. 2 times 2, 4. 2 times I, positive 2I. Negative I times 2, negative 2I. Be careful on the last. A negative I times a positive I. A negative I squared. So the middles cancel, and we're left with 4, subtract 4 minus I squared, which is a -1. So 4 minus a -1 becomes +1. The answer is 5. So our denominator is 5. Now reduce it, put it in complex form. The real part, 5 divided by 5. 1. And the imaginary part, 5 divided by 5I plus 1I. So your answer is 1 plus I. And that's division. And again, I know it's weird. Adding, subtracting, and multiplying is intuitive. It's what you do. Division is the weird one. It might even require a little spot on that note card for Monday to remind yourself these words. Multiply by I if you're dividing by a pure imaginary. Multiply by the conjugate of the denominator if you're dividing by a complex number. A lot of vocabulary, right? Just said a lot of vocabulary even in that statement. But all right, that'll do it. That'll do it.